scanning networks, right? So scanning. During ethical hacking, scanning plays a major role, right? So during ethical hacking or even hacking, scanning perform a major role. So there are 5 phases we remember during we discuss during the hacking. So first one is information gathering. The second one is information gathering and reconnaissance. And the second one is scanning and enumeration. Third one is gaining access. Fourth one is maintaining access. The fifth one is covering tracks. So these are the 5 phases of hacking. First one is information gathering and reconnaissance. The second one, information gathering, is collecting information as much as possible from the target. The second one is scanning to pull out more specific information about the target, like version numbers, the services running. And then we know open ports. So ports are the way that you could enter to the target or compromise the target. So scanning and enumeration. This is a single phase, but 2 techniques. Scanning is collecting, retrieving information. Enumeration is more specific information, like pulling out usernames, group names, device information, right? Even passwords for that matter. And the gaining access is you're using a mechanism to compromise the target. That is gaining access. And then the maintaining access is since this pre-hacking phase. So this is these two known as pre-hacking, right? This is the real hacking phase, gaining access. This is post-hacking. So pre-hacking usually takes 75% or more from the total time in typical attack. So attackers have to invest a lot of time to collect information, because the thing is, more information you have, you are in a better position to gain the access. Because of that, information gathering and reconnaissance, scanning and enumeration usually time consuming, right? So the scanning is collecting information. So if you specifically looking at a host scanning, what are we going to achieve by scanning? That we need to understand. So achieve meaning we are trying to collect information related to the open ports. Then we need to understand what are ports. What are ports? If I ask this question, what do you think, guys? What is a port? We know some ports like printer ports, USB ports. So ports are actually interfaces. Again, standard interfaces. So because of that, standard interfaces used to communicate. If we say printer port, you don't have to say it's this type of a port or something like that. So if it is VGA port, you don't have to explain it's a blue color one and there are a number of pins out there. You don't have to. Even USB, you don't have to say that it's a square type one and 16 pins are there. You don't have to. It's standard. But there are 2 types of ports. One is physical ports, which are tangible, you can touch and see. The other one is logical ports. So what are logical ports? Same thing, standard interface. Because the reason is, if you take a host, right? In order to communicate with the host, main thing that we use is IP address. Remember, we have IP address, right? So any device which has assigned IP address can be treated as a host. So if you perform host discovery to understand what are the hosts that are on your network. So during information gathering, we can do that. So for example, if I open up my command prompt, if I do ipconfig, so you could see my IP address is this one, 192.168.50.54. And at the same time, we can start pinging 192. 168.50.1. Oh, it is pinging. We know this host is up now. And then we can start 2. It is not responding. Then we can start 3. Likewise, we can go all the way up to 255 because we know the range starts from 192.168.50.1 to 254, sorry. But this is going to be time consuming. This is known as ping sweeping. For that, we can use tool like Angry IP Scanner. All right. So if I type 1 to 255.254, I can scan the range, guys. So Angry IP Scanner is a free tool where you can use to conduct ping sweep, meaning using ICMP protocol, we are going to ping each and every IP. Right? You can see these are offline hosts, whereas this one is pinging, and you can see it is, if I do, is HFLPT230, looks like a printer, but we don't know, right? So that you can see, and also everything that is connected. This is my device, obviously, 50.54, and this one is, it seems like 23 Ultra, which is Samsung, I think, Samsung mobile phone, and this one is again another one that you can see 142 is open. Likewise, you can see that. Okay, so this is the IP address. So once you found it, so this is one of the mechanisms that you can address this one. But the thing is, single host can run multiple services. So in that case, how are we going to specifically communicate with the specific service? How are we going to do that, right? So how are we going to perform that? So if we are communicating with the host, we can use IP address. But what if this host has multiple services running? So then what is the mechanism? I will give you kind of analogy. Now let's say you are requested to visit a workshop in a hotel. Okay. So then somebody has, the organizers has shared hotel address. Even when you go to hotel has so many rooms. So you don't know which room this particular program is hosting. So without knowing the room, you can't go directly there. So you can go to the hotel, but we don't know which room that you need to go. Probably the same hotel, same time, there can be multiple programs running. For that, we need to know the room number. Something similar to that, if you want to specifically communicate with specific service, we use a port. Port is a standard interface to communicate. For example, there are ports like, everybody knows port to 80. Port 80 is used to communicate HTTP communication or WW traffic, World Wide Web. So if anybody is hosting a website, obviously port 80 has to be open in order to communicate. And then if you look at a port like 21, FTP. So if you're hosting FTP host, then you need to know 21 has to be open. So now you can see single IP address, but multiple ports to make sure the communication is properly, properly done. So that is there. So I hope you understand. That is a port. This is known as virtual ports. So if you look at TCP/IP stack, TCP/IP packet. So let's say TCP/IP packet. So there are some. This is 32-bit. So there are some fields allocated like this. So the first field is always source src IP. The second one is destination IP. So usually, these are 32-bit fields, right? 32-bit fields. And then there is another field known as source port, destination port, right? So destination port and source port are important because then we know how the interface is happening, right? What is the source port? What is the destination port? These are actually 16-bit each. 16-bit each. So then the total number of ports available in any communication in a computing system, if you're using TCP/IP, it has to be 2 to the power 16. 2 to the power 16. The meaning, the number is 65,535. So 0 to 65,535 virtual ports can be addressed in a host, out of which 0 to 1024 are known as known ports. Why? The reason is all the known commonly used services have already allocated between 0 to 1024. For example, port 20 is 2021 is port FTP, 22 is SSH, 23 is Telnet, 25 is SMTP, 80 is web. Likewise, the range is allocated. So if you are to create a design a program, 1025 to 65,535 are available for us to. Those are not allocated or common ports. You can use them for the communication, right? I hope you understand. If you have any questions, please do ask. And there is another important thing, because these packets are sent and received between host and the client and server. Always we are talking about client-server communication when it comes to the distributed computing. So you send a packet, receive packet, send packet, receive packet. So then how are we going to distinguish these communication? For that, we use a method called flags. There are 6 flags allocated for determine to specify the type of the packet. So these are known as sync packet, ACK packet, push packet, fin packet, reset packet, and urgent packet. These are the 6 types of packet. Sync packet. Sync packet is usually, what it does is, in the sync packet field, you have bit, sync packet, it's a single bit, space is allocated from the packet, single bit. So this particular location, if one bit is present, meaning it's a sync packet. So application of sync packet is to say we are going to start communication. Always sync packet will be sent if you are going to start a communication. The acknowledgement is, ACK packet is acknowledgement. If you receive a sync packet from someone, from a source to destination always supposed to send acknowledgement packet for the received sync packet. Because we know there are 2 types of major protocols that we are talking about, TCP and UDP. So UDP is known as connectionless communication. TCP is connection oriented. The meaning is we use TCP protocol to validate the communication. If you're sending, you need to validate it's being received or it's received by the recipient. UDP, we don't care actually. We are sending. We don't know whether they received or not. So that's the reason UDP protocol is usually used for that streaming kind of communication. Streaming communication. You send, that's it. Your responsibility is done. It is not your responsibility to verify whether user received or not. That's up to them. But the TCP, we need to verify whenever you send a packet, we need to know whether it's received. Okay. So then whenever in TCP communication, if you send a packet, you need to get an acknowledgement. So that's where the acknowledgement packet, push packet is to, create kind of a buffer. Fin packet is to say it is the last, finish. Communication is completed. RST is for some reason the packets are not being received or not received. So we can say reset the session and then start sending packets again, because there are so many packets during the communication, right? And then urgent packet is something like we need kind of priority. So that is urgent packet. So I hope you understand. So then we use these flags to perform the communication. Guys, please, if you have any questions, please do ask, right? So this is the communication, 3-way. And then the next thing is using this packet. How do we know during client-server communication how this work? Now let's say this is a web server, right? for easy explanation, I'm going to draw, let's say this is the client. Client meaning a computer, and also it has a web browser. Let's say web browser. And then we type, now let's say this server is hosting a website. Port 80 is open, right? So we are going to start the communication. And also remember, always servers are listeners, right? From the designated port, they keep on listening through a designated program. So in this case, it's a web server. Obviously, it uses web service, something like Apache, IIS, Nginx kind of a service to listen to the communication. They're happy to communicate, but they're listening until somebody sends a request. Okay, so then let's say this particular web server is hosting sample.com, right? So what client would do is client would type sample.com and press enter on the browser. When that happens, built-in DNS client on to the operating system would recursively find out what is the IP to the sample.com. That is a DNS query. Now let's say this particular web server is hosted in 1.2.3.4 is the public IP address. We know in order to host a web server, we need to have public IP address. Then client would know after DNS query, sample.com is hosted on 1.2.3.4 IP address. This is just a hypothetical IP address. Don't worry about it. Just a number. Okay. Now, once that is known, what our browser does is browser start to establish a connection with the server. So that is where three-way handshake happens. What is three-way handshake? This is actually performed before any communication. Before starting any communication in client-server communication, we use three-way handshake. What is three-way handshake? So three-way handshake is sending sync packet to start communication first. Sync packet. It's something similar to when you met a friend on the road, you ask hi, and your friends also say that hi, and you said how are you, likewise, right? So there's you start, after that you start talking. So same way, client server communication, while server is listening, client send a sync packet. And then once this is received, server acknowledging this packet with acknowledgement packet. And then along with that, server sends sync packet again, because server also has to say hello, right? And then client would respond with the ACK packet. So this sync, ACK, known as three-way handshake. Is it clear? Make sense? Sync, ACK, and ACK. So then the question is, any given time, server would expect thousands of requests from the clients. It's not single client to single server. So the server is there. Sample.com can be used or trying to access by so many people at the same time. So how server is going to cope up with this? So what it does is, actually when they are sending sync packet, it goes with something called sequential number. There is a field here for the sequential number as well, right? Sequential number, SEQ number, sequential number. So then with the sync packet, typically a client send a random number called sequential number. Now let's say sequential number is 1, 2, 3. Okay. And then whenever server receive, it's a lengthy number with 32 bits. So whenever to easy understanding, I'm just referring this as 1, 2, 3. And then whenever you receive this sequential number with sync packet, the web server respond acknowledgement with the sequential number too, right? The importance of this sequential number is always the received sequential number plus 1. So in this case, he would send 1, 2, 4 as a acknowledgement. Then client knows, all right, I receive an acknowledgement packet with this particular sequential number. So this must be acknowledgement for the previous sync packet I sent to sample.com. So then client can understand how he would receive this acknowledgement packet, or which packet he received the acknowledgement number. And then the sync packet that web server sending, that also goes with a sequential number. It's a random number again. It's a separate different number. And then when client respond to the acknowledgement packet, again the same thing, he would add 1 to the acknowledgement number. So then server would know among so many acknowledgement packets, server can understand, all right, this acknowledgement packet I received to the sync packet that I sent before to this particular client. Okay, so this is known as three-way handshake. Before start any client server communication, three-way handshake happen. Okay, and once the communication is over, server responds with fin packet. Final, finish, no other communication. If the communication is interrupted or something, depending on the system, even we can expect a reset packet as well. Fine, finish, or reset. So reset meaning not respond, or communication is interrupted, or no more communication again. Okay, so I hope you understand. Now let's say, now I hope you understand and you have kind of you understood the concept. Now my question is, now there is a web server, there is a server or a target. There's a target, and we know the IP address. And this is my testing machine. I want to know, and obviously I know whole range of ports are 0 to 65,535. If I wanted to know what are the entry points for the server, what are the open ports, are something similar to a burglar or whoever trying to break your house would try to find out where the windows and doors located, because those are entry point for the house. Same way, cyber attackers would try to find out entry points through ports. That is easy way of doing that, right? That is one of the common ways of doing that. So I hope you understand why, because otherwise you would be thinking why these guys are going to so desperately finding port numbers. Now tell me a method where this tester using testing machine to find out if there are any ports open, or if that's the case, what are the open ports? Tell me or suggest me a method. You get me? You got my point, right? I hope you understand what I'm saying. How we can find out what are the open ports? Is there any method? I'll give you a couple of minutes. What do you think? A scanning, that's correct. A scanning is method. So what I'm asking is, are you spot on? You're correct. What I'm asking is not just a term, how a method, what type of method that we can use to find out whether the target has any open ports or no, or if there are any ports, whether it's open or not. I think you're closer to the answer. So what I'm saying is, if I send a sync packet, now three-way handshake we discussed, sync act, right? So if I send a sync packet to specific port, now let's say we are going to specify port 23. I'm going to send a sync packet targeting port 23, because we discussed always packet goes with the source IP and destination IP. So the source port and destination port. So what I'm going to do is, we know source IP, we know destination IP. Then I'm going to say destination port is port 23, and I'm going to send a sync packet. Then what would I expect from this one? I expect acknowledgement packet from the server if the port is open, isn't it? Are you agree or no? Do you agree? I send a sync packet to specific port, in this case port 23, and then I expect acknowledgement packet if the port is open. And if I receive fin or reset packet, meaning port is disturbed or port is closed. Do you agree? Do you agree or no? So I send a sync packet, that's what I'm going to do. Sync packet, I'm going to send sync packet, and I receive acknowledgement packet. Oh, I know port is open. If I send a sync packet and if I receive a reset packet or fin packet, I know port is closed, isn't it? Is it clear? So that is known as, guys, so that is the technique behind scanning, nothing else. Scanning is leveraging three-way handshake and then getting required information. For that, we are using plenty of tools. And in even scanning, there are two major scanning methods. One is known as full scan. The other one is known as half or stealth scan. First one is full scan, the other one is half or stealth scan. Why? The reason is the purpose. If you are an administrator, if you still want to find out whether this port is open or closed, this administrative duty, you just perform full scan. Full scan meaning you're performing complete three-way handshake. Because you don't care, completing three-way handshake and also it's known as noisy. The recipient would know someone is trying to scan or someone is scanning. But if you are an administrator, you don't mind because it's legit. But what if an attacker? You have seen, right, in cartoons, if somebody is robbing or if they are doing something, some secret thing, they don't make noises. They don't want to make noises. They want to do something, if it is fishy, they want to get something done and quickly leave the place. For that, they use half scan or stealth scan. So attackers mainly use stealth scan. The difference is they use half scan, meaning they send sync packet. They would wait until they receive the acknowledgement or reset packet to see whether the port is open or closed. Actually, you don't have to complete three-way handshake to know port is open or closed. From the response that you receive, you would know port is open or closed. Attackers, by this point, they would reset the conversation. They will not send acknowledgement packet for the server again. Only they do half scan, only first two steps of three-way handshake, sync, act, only that. But full scan, sync, act, right? So full scan is noisy. Usually administrators perform that, but half scan is stealth. Then you must be wondering, how can it be stealth? Why server doesn't know he's under scan? Because the reason is there can be so many incompleted three-way handshakes are happening, every second for a server. Because of that, half scan is not something that servers has to be worried of. So because of that, half scans are usually goes stealth. Okay, so and it's not noisy. So this is what we wanted to know.